Staying with 3D PT, TinkerCAD just came out with Sim Lab, which lets you make dynamic objects in TinkerCAD. And they're definitely going to be adding to this in terms of different shapes and geometries in the future. But right now, I'm just going to do some quick tests and some tutorial designs just to kind of play around with the capabilities. Now, what's nice about this is you lay it out in 3D design mode like you do a normal 3D printable object. And then up here in the corner, that falling apple shape is your dynamic options. And I'll go through and show you how to set up a basic domino fall and go from there. Now with this right now, you only have the work plane that's shown as the workspace you can work in. So you can't make any paths go off grid right now. And that's probably a good thing because if you let your students go too far out, they're going to run it forever or they're going to do something weird. And also it's going to eat up a lot of processing power. So this would be a constraint in engineering where your students have to work within a certain area. And so make sure to cover that. And that's part of the challenge is you have to make it fit within this grid, which is 200 by 200 millimeters. And so you have about 20 centimeters by 20 centimeters area to work in, which is actually good because that's the build size of most build plates on desktop printers. This was another great constraint because if your students want to make something like a marble run or any sort of Rube Goldberg machine, the challenge is it would have to fit within that volume. So first thing I'm going to do is I'm just going to drop down and make a basic domino. It's about 5 by 20 by 40. Now you could actually measure a real domino, or I just eyeballed this. For this, I'm just going to make a straight run going diagonally across the grid. So I'm going to rotate this. Now in TinkerCAD, if you want to rotate, you can see here how I've got the protractor set up. Now always remember you can do this in the steps of 45 degrees by holding down the Shift key. And that changes your protractor to 45 degrees. And this actually is a trick you really want to cover with your students because if they try and freehand it, it's going to be really difficult to get the exact right angle you want. And you can type it in, let's say minus 15, but your students are going to screw that up. So make sure you emphasize the shift protractor so you can do that. So once you have it rotated, you're going to use the duplicate command next to make a line of dominoes. So duplicate is up here on the left-hand corner. It's a 2 squares icon, or Control D. So you click on the object, Control D, and then you just move it about what you want. And once you let go, that sets the command for. Once you let go, that programs that duplicate function to multiply and keep hitting, to keep expanding the dominoes as you go along. Forward. Now Control D. That sets up my whole array of dominoes ready for the fall. Once you have your dominoes lined up, you're ready to start the animation next. So in the upper right-hand side of your screen, you've got this new icon here, which is your Sim Lab. So you start with 3D design here. You have Sim Lab. You have blocks from Minecraft. Bricks for building blocks. as well as an invite, so you could invite your teachers and your account settings here. So I'm going to click on Sim Lab and set it up from there. Lab button, and it brings you to this new environment here. So you still have all your camera controls. You could pan around, but you also notice down here you have a play screen or a play button and share. So here's where the fun begins, because right now you basically have a stack of objects you could throw at play button, and you could use the mouse to throw objects, or you could tap on the screen and try and figure out how to do this. So if your screen is touch enabled, you could definitely have fun trying to do that. And you could also pan around, I think, while you're moving. So I'll try and do both. So as I did this, I couldn't do two things at once. So I could only throw, or I can move, or I pan. So it's going to be a little bit jerky on the animation, but it's going to be something like pan, throw, pan, throw. So play. And the longer you hold a click on on the object, the harder it throws. So 1, 2, 3. Play 1, 2, 3. Whereas if I just click on it, it just kind of chucks it. But if I hold it, and as you do this, like if there's things you want to move, you could definitely do that. Or if something's out of line, you could always hit reset. And like, let's say you have to go back to your design space to move, but move those, make them different colors, and I want to shift them. So here's where you get to start having fun. If you click on any of these objects, you notice that your menu comes up here and it says materials and color. So you can change the color here, and you could also make it dynamic or static. Now by default, they're all dynamic, so they'll all move. But if I want to put a challenge, like I want to basically nail that to the ground, I can make it static. And when I do that, it gets a purple outline around it, and it won't move when I run the animation. So let's see if we can do this. And you have to reset the scene if you want to make any changes. Now, another cool thing is right now, the default material is plastic, and it gives you some cool things here. So you have to be in dynamic mode to read them, but it tells you what the coefficient of friction is. Restitution is how much it bounces. The density of the material, and this is a set property based on real life things, because density of any material is measurable and fixed. And based on the shape, it'll give you the approximate mass. And because mass is a function of volume, or I'm sorry, density is a function of mass and volume, you could actually go from the volume to calculate and density to get mass, or mass and volume to get density. Now, right now, it has a fixed menu of materials. So let's see, its default is plastic, concrete, ice, polystyrene, rubber, steel, hardwood, softwood. Let's see. And every time you change the material, it'll give you a different density. And if you have a set of density cubes in your class, you could actually bring these out and kind of show a demonstration of what these different densities look like. Right now, it doesn't give me the option to change any of these properties. It just has grid material. But in the future, I'd actually like to see a choose your own material, basically, where you could type in the factors like the density, um, or either add texture or add just by changing the density and friction. Let's see, I think if you could change the density, friction, and restitution, those are the three properties that will really impact how much it moves and how much it bounces. And you could have fun, like you could do simulations where you could do something super dense like lead or depleted uranium, or something super light like aerogel. And you could explore how the properties will kind of move it around and how easy it would be to bounce around. So that's probably something I hope they have in the future. I imagine right now TinkerCAD's just trying to get through all the um, learning curve and bugs on this. So on each of these menus and materials, there's different physical properties that are coefficients and some math based on the properties of the material. So for example, if I change this block to concrete, it has a friction of 0.65. That 0.65 is called a coefficient of friction. And it's a fancy way of saying, here's a number to measure how rough or smooth something is. Obviously, the closer to 1 or you have objects that are pretty much really just kind of stuck together. Coefficient of friction of 0.65 is what you expect for something like concrete. So the next one is restitution. And I had to look this up. There's actually, of course, there's a scientific measure of how much things bounce back. So that's called a coefficient of restitution, and it's symbolized by a bold a bold italic letter, lowercase e. And the higher the coefficient of restitution, the less likely it is to bounce. So something like steel is 0.85, where rubber is 0.03. Something like ice, which we've seen bounce around, is 0.75. And so that coefficient restitution is set for the material. Again, in the future, I'd like to be able to play with that and have like a mystery cube we can play around with. There's also a famous demo I've seen on this where you have two bouncy balls. One of them is made with regular bouncy ball rubber, and the other one is made with vulcanized tire rubber. And when you drop them, the vulcanized one stops because its coefficient of restitution is, I think, close to 0.85, whereas the normal rubber ball is at 0.30, so it'll bounce. I'll try and include a link or clip in this demo here as well to show you the difference. The next property on this is density. So if you have a set of density cubes in your classroom, go ahead and get those out so you could show the difference in how density is independent of volume. Because you can have cubes that are the same dimensions, but because the material is more or less dense, will feel more hefty in your hand. And the symbol for density is the lowercase Greek letter rho, which looks kind of like this nice kind of cursive um, lowercase p. But a lot of times when it's used like in your classroom or if you're learning about density, um, it's oftentimes just substituted with the letter lowercase d. Um, and you could go down the rabbit hole of different things you could do with density, like you could do different liquids. But for the Sim Lab, the density is kind of the fixed property of how heavy or chunky the material is. Because if it's more dense, it's going to have more mass, more inertia, and be harder to move. So here it shows the mass of the object. Now remember, mass is the amount of stuff something has in it. And so obviously the bigger the volume of the object, the more mass it's going to have. Also, how dense it is going to determine its mass. So this also controls inertia, or how much something doesn't want to move. And so so if you think of it like if you're trying to push a very heavy object, that has a lot of mass and has a lot of inertia. Whereas if you're just pushing a feather that has a very low mass, then it has very little inertia. And you can use this to actually, if you want, simulate inertia or collision car labs. And I'll work on a lab for that in the future. But this property is based on the volume and density of the object. And if you want to find the mass of it, you could divide the density by the volume of your object. So the final property that's listed in this menu for each material selection is volume. And that's obviously length times width times height, or base times height. So you can practice your geometry here. Also, you can see the correlation between volume and mass as if you change the size of this. So you could practice volume and geometric properties here. And here's a cool joke. You have mass and you have volume, therefore you matter. Any object has volume, it takes up space, and it has stuff inside of it, or mass. Now, everything that's around us that we could touch and feel, including the air and liquids and all sorts of things, take up space and have mass. Therefore, it's matter. So if you're ever feeling down on yourself, remember you have mass and you have volume. Therefore, you matter. So a nice feature also is um, on this menu, you can make a thing static, or next to it, you could also hide it. So I click on that and hide that green cube. This could come in handy for a couple different reasons. If you're not sure how that part's going to look or work, you could take it out temporarily. Instead of deleting it and try and put it back in, you could just hide it. Also, sometimes there's what are called ghost parts in 3D printing, where you basically do a set of movements to hide, to do some sort of workaround in your toolpath that doesn't actually show up in the print. You could also do it here to create hidden supports or other things you might need in the future. So let me try and show an example. So here's an example of a ghost part. I'm going to make the green and red dominoes hidden. Just hide those. And now when I run the simulation, um, do that, or if I throw something underneath, it'll go straight through. Now, the last thing you do is actually record this as an animation. And so once you press play and it records how you throw and do other things, then you could actually record it and share it. So to have some fun here, I just changed the different properties. So some of these are cement, wood, plastic, ice. And by changing that, you can check different things at it. And this one here is actually static, since you could see the purple outline around it. That's a steel cube. And I can check that. So by having that ghost part there hidden, goes right through. Now, the cool thing is once you played with it, you can actually share this video. And so you click on the share icon here. You pick your aspect ratio. So 9:16 is good for shorts. 1:1 is Instagram, and 16:9, I believe, is I think that's regular video. So I'll do 16:9 on this. And then I could save the image as a short, as used as a thumbnail, and create the video. And my experience, this takes a minute to render, and I'm using Microsoft Edge right now. I didn't have any luck in Firefox getting it to run, so you'll just have to see what you do. And the rendering probably takes a few minutes, especially the longer you play with this, so be aware of that. So when you get to the point you're rendering the video, you could change the aspect ratios here from 16:9, 1:1, 9:16 for your cell phone videos. You could also save, adjust what image appears here on the slider. You could save the image as a JPEG, as a PNG, and use this for a thumbnail. And then you create the video, and it downloads as an MP4. And so this is the final rendering for this test video. And you can see how it throws from pretty much your perspective on the screen into the environment. Just knocks it down. It'd be cool in the future to also incorporate this into code and see about coding in either Scratch or some other coding with this.